Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good day to all. My name is Muhammad Farid Izwan bin Muhammad Supian, and I'm from School of Electrical Engineering. My matrix number is 2023633646. Currently, I'm just starting my first sem and taking my PhD in Electrical Engineering under my supervisor, Professor Madya Senior Technologist Dr. Said Abdul Muttalib Al-Junid Said Abdul Rahman. Today, I would like to present my progress report with the title on enabling digitalized embedded electronic architecture sensing strategy for monitoring in robust application. Before I proceed to the slide, this is the content which I'm going to cover in the slide. Firstly, I will begin my introduction. Then we go to the problem statement. Next is objective and the literature review. And then we go to the Gantt chart as a guideline for me to make sure the progress is on track. And lastly is the next SEM work or planning. Let me begin with the introduction. What is embedded electronic sensor technologies? Embedded electronic sensor technology is the integration of the sensor and processing function into a physical object. It is a key enabling technology for the Internet of Things, or we also know as a IoT, to collect and exchange the data, which can be used to improve the efficiency of the process. This technology can be used to monitor the critical asset and detect potential problems at early stage to prevent failures and reduce the downtime. There are the numbers of benefits to using the embedded electronic sensing for the critical asset monitoring. The first one, embedded sensors can be placed in the location that are difficult or impossible to reach with the traditional sensors. This allows for the monitoring of the critical asset that are not easily accessible, such as in the remote location or the risky environment like a power station. And the second one, the embedded sensor can collect data continuously and providing the real-time information on the condition of the critical asset. This allows for the early detection of potential problems before they can cause the failures. And the third one is this sensor can be interconnected or integrated with other devices or to create a network sensor that can monitor multiple assets at the same time. This allowed for the collection of the large amount of data which can be used to identify the trend and patterns that may not be evident from from monitoring individual assets. Here are some examples of how embedded electronic sensing is being used to monitor the critical asset today. In the transportation system, these sensors are being used to monitor the condition of the trains, aeroplanes, and other vehicles. And this information can be used to detect any potential problem early, such as worn bearings or cracks in the component. The second one, in the power grid, embedded sensors are being used to monitor the condition of the power lines, transformers, and other power grid equipment. This information can be used to detect the potential problem early, such as overheating, overloading, or the in the fault conditions. And the last one, in the medical devices, embedded sensors are being used to monitor the condition of patients, such as their heart rate, blood pressure, and oxygen levels. This information can be used to detect potential problem early, such as heart attacks or the strokes. Next, we go to the problem statement. For the problem statement, I categorize it into two categories, which are technical and non-technical challenges. For technical challenges, the first one is a lack of low-cost, reliable, and energy-efficient embedded sensing technologies. Existing embedded sensing technologies are often too expensive or too bulky for use in the critical asset application, which may be located in the remote or inaccessible location. Additionally, these technologies may not be able to meet the reliability and energy efficiency requirements of the critical asset application. And the second one is a lack of algorithm and software for processing and analyzing embedded sensor data. This data can be noisy and incomplete due to the variety of factors such as environmental interference and sensor failure. This makes it difficult to extract the meaningful information from the data, which is essential for effective critical asset monitoring. And the third one is a lack of methods for integrating embedded sensing system into critical asset application. Critical asset application are often complex and safety critical, making it difficult to integrate with new technologies such as embedded sensing system. This is because any changes to the application must be carefully designed and tested to ensure that the safety and the reliability of the system are not be compromised. And in additional to these technical challenges, there are also the numbers of the non-technical challenges associated with this embedded electronic sensing for the critical asset monitoring. The first one is a lack of awareness and understanding of the technologies. Many organizations or premise are not aware of this benefit embedded electronic sensing for the critical asset monitoring, or they do not have expertise to implement these technologies. The second one is a lack of the standardization. There is a lack of the standardization in the embedded sensing technologies, which can make it difficult to integrate sensors and software from the different vendors. Then the last one is the security concern. Embedded sensor system, the system can be vulnerable to the cyber attacks, which could have serious consequences for critical asset application. These challenges must be addressed in order to enable the widespread adoption of embedded electronic sensing for critical asset monitoring. Moreover, the critical challenges in embedded electronic sensing for the critical monitoring is the development of low-cost, reliable, and energy-efficient sensor that can be integrated into the complex and safety critical system. This sensor must be able to operate in a harsh environment and collect the accurate data under a wide range of conditions. Next slide is my objective. The objective of this project is to develop new embedded electronic sensing technologies, algorithm, and software for critical asset monitoring. The specific objective of this project are two. The first one is to develop new embedded sensing technologies that are low cost, reliable, and energy efficient. This will enable the widespread adoption of the embedded sensing for the critical asset monitoring, particularly in the application where existing technologies are too expensive and bulky. And the second one is to develop the new algorithm and software for processing and analyzing the embedded sensor data. This algorithm must be able to handle the noisy, incomplete, and high-dimensional data in the real time on embedded devices with the limited computing resources. And last one is to develop the new methods for integrating embedded sensing system into critical asset application. This requires careful design and testing to ensure that the safety and reliability of the system are not be compromised. Additionally, the system must be able to communicate with other systems and devices in order to provide the real-time information on the condition of the critical asset. This is the objective progress that I'm setting and planning to do and planning and counter check the work of this project. For this semester, the progress is not yet completed, and inshallah, I will start it for the next sem. Since this title just have been decided by me and accepted by my supervisor and the faculties. Next is the literature review. This is the journal and article that I've read regarding the topic that I chose. So far, I read 12 journals, which consisting the area of the transformer monitoring, transformer health analysis, machine learning for the transformer monitoring, and transformer digitalization. This process still continue from time to time. Okay, this is a slide. Uh, this is the literature review. Okay, next is the Gantt chart. Okay, this is the Gantt chart for the whole semester starting October 2023 until 2025 as a guideline for me to make sure this project is on track. I will update and improvise the Gantt chart from time to time. Okay, this is a Gantt chart for this sem. As we can see here, there's a lot of the activities that I did in this sem. Okay, lastly is the last slide is the next semester planning. So this is the list of activities that I'm planning to do for next sem. This is the first one is to continue with my literature review, which I will keep reading and learning more about the topic that I'm focusing to find the new information and ideas from books, articles, and other resources. And then the supervisor and co-supervisor meeting, I will continue to do the frequently meeting and meet my main supervisors and my co-supervisor to update and talk about how my research is going and asking for their advice. Next is the industrial visit. I'm planning to do a site visit at least one of the industrial that related with my research to see how the things work in the real life, and this will able to help me to gain the information or the data will help me to understand my topic better. And then I try to do the review. I try to review, revise, and update my report, which based on the discussion with my supervisor and my co-supervisor lah. Next is the starting and focus to do the objective one as stated in the previous slide. And last but not least is to submit the article 3 that related with my research. And that's all from me for the progress report for this sem. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.